All right, so let's see what we got here. So we've got a B is 1. It's supposed to be a B. B is 1, Q1, Q0, and F. And we start like that. So, and we make sure we have the correct connections here. Got that. Okay.
Don't forget to change it to.
Yes, to Q0. Okay, so when we start, this is 0, this is 0, B is 1. So Q bar down here is going to be 1. But on the next clock cycle, I want to look at what is sitting there right now. So, well, okay, so for the first clock cycle, it is the AND of 0 and 0, which is 0. Okay, now before we change the B, let's see what happens. We've got the OR of 1 and 1 is 1, and B is 1. So that means Q0 should toggle. Q1 should be 1. F should be 1. And now the clock changes and the clock becomes 0. So now B is 0. So I've got a 0 here. But on the Q0 was 1. So that made this 0. And this was 1. So this is 0. So Q bar is 0. So I've got a 0 over here. So I've got
still get a 1. Oh, wait, no. Yeah.
I'll get a 1 for Q0. And what do I get for Q1? 0. And for F? 0. Okay, so
we're basically using B value
from the time before. Yes, and I did that on the first step and then did not do it from there on out. But let's do that. Let's go ahead and finish filling this out. So now I can put the 1 in, but I don't change. I put in my values of Q from here. So Q0 was 1. So Q0 bar is 0. So that's 0. B is 1. So it makes the OR of 1 and 0 is 1. B is 1 down here. So that'll make Q0 toggle. And Q1 will become 1. And F will be 0.
You put the next B.
Yep, and I also put that Q0 is 0. So Q0 bar is 1. So I have a 1 over here. And B is 1. So I have a 1. So Q1 will be 1. Q0 will toggle. And F will be 1. And then on my last one, Q0 is 1. So Q0 bar is 0. So I have a 0 over here. And what is B? B is 0. 0 or 0 is 0. So I have a 0 here. So Q1 is 0. Q0 is 1 because it doesn't change. F is 0, and there's no B input here because you're always using the B from the time before.
Lovely.
Okay, so glad you asked that, and sorry I made the mistake. I hope I hope we're less confused. Okay. Where is there? Okay, so the thing with the Verilogs that you're going to see is that they are likely to fall into this same sort of pattern where, because that's what y'all are doing this semester, are sequential circuits. And so this is going to have, they're usually going to have a number of flip-flops. And you can usually tell how many flip-flops by looking at your parameter, and that's usually going to tell you how many flip-flops you have. And so when you look at something like this, you see a for loop, you see that you have your Q is a vectored signal that it goes from n minus 1 to 0. That means that Q is going from 2 to 0. That means you have a Q2, a Q1, and a Q0. Well, right there, that tells you how many flip-flops you have. And so even if you had just guessed 3 before, we now know 3 because that's why we're using the variable Q is for the flip-flops. So we're going to have 3 flip-flops. And so you can almost always start these the same way, even if you're not entirely sure. And this will give you some confidence because you'll have something to do. So you can start by drawing your 3 flip-flops. Use D flip-flops. There's no point in using T flip-flops if you don't have to. And you'll have a clock, so you can always draw that in. You can always put in the signal to the clock. So there are all things you can do if you see the Verilog and you start to panic. If you see any if statement, that probably means that you've got a multiplexer, and you'll have a multiplexer going with each flip-flop, because that's what a multiplexer does. It's your if statement. And the output from the multiplexer is your input to your flip-flops. We may end up changing these, but this is a good way to always start setting them up. We'll put a 0 and a 1. And I'm putting a 0 and a 1. If I had a case statement, and my case statement had 4 things in it, then I might put 0, 1, 2, 3, because it might be a 4 to 1 multiplexer. And then I see that I've got some output B. I don't know where that's going to be yet. The integer J, that's just my counter. That's for my for loop. So let's look at our for loop. Our for loop starts at J equals 0 and continues for J less than n minus 1. N is 3. N minus 1 is 2. And it's less than n minus 1. So this for loop is actually only going to go twice. It'll go for J equals 0 and J equals 1. So let's start with J equals 0. It says if Y. Okay, this if, that tells me what to do with my multiplexer. So Y is going to be a variable that goes to my multiplexer. Right now, I'll put it into all of them. I may take it out later. I'll number my flip-flops 0, 1, and 2. Right now, I'm working on 0. It looks like I might not need the multiplexer for flip-flop 2, since my for loop only has J equals 0 and J equals 1, but we'll find out later. So if y, so this is for y equals 1. For y equals 1, that means we're talking about the one input on the multiplexer. Q of 0 becomes equal to the naught of Q of 0 plus 1, or the naught of Q1. So I can, Q is right here for all of these. If I don't want to put a NOT gate in, which I don't, I can put in a Q naught down here.
And this is only when y is equal to 1.
Right, and that's why I'm putting it into the 1 of the multiplexer.
So, what is y? How is y getting inputs?
Right here, it's a switch somewhere that is the input into these multiplexers.
Oh, I see. Okay, I see. So if y is for 0.
How did you know which Q naught it was talking? Oh wait, because it's Q. Oh, because it's not Q, not 1.
It's Q0.
Oh well. Oh, I'm asking about like how do you?
Oh, it's not Q1. Right, and this is 1.
Okay, and that's why you put in the FY1. Okay.
No, I put in the y equals 1 because if y. So if y means when y equals 1. But right now, I'm in my for loop with j equals 0. So j equals 0 right now. And this line right here with j equal to 0 says q of 0 is equal to q of 0 plus 1. Or not q of 0 plus 1. Or q of 0 becomes equal to not q of 1. And so here's q of 0 becomes equal to the naught of q of 1, but only if y is 1. That's why it's not going straight into Q0.
Oh.
Instead, it's going into the multiplexer, and it's going into the 1 of the multiplexer.
Okay.
Did that answer your question?
Yes.
Okay. Mm-hmm.
Q of 0 goes in the naught of Q. So 0 plus 1.
Okay, taking this line right here.
Oh, because j is equal to 0.
Mm-hmm.
Okay. And then the naught of that is just 0.
J is 0.
Yeah.
So I just replace J with 0. Q of 0 becomes equal to the naught of Q of 1. So this is Q of 0 right here. This is Q of 1 right here. The naught of Q of 1, I'm just putting it right here. I want Q of 0 to become equal to the naught of Q of 1. So if there was no if statement, I would just have it go straight into here. But there's an if statement. It only does that when y equals 1. So it's going through the multiplexer.
And so will we do the same, like, kind of thing to figure out the values of the 0 and 1? Flip-flop 1.
We'll get there. Mm-hmm.
But why is it less than or equal to? Shouldn't it be equal to this?
That less than or equal. That's that like sets it to, right?
Yeah, that's not less than or equal to. This is the non-blocking assignment. So inside an always loop. So always at blah, 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 blah. The things in here, by the way, if you change things in an always loop, they have to be labeled as reg. Notice that the Q is in fact labeled as reg. I can make, okay, let's say I didn't have the non-blocking, and instead I had Q of 0 equals the naught of Q 0 plus 1. Then that means that this Q of 0 will immediately become equal to whatever this one is. But next, if I'm making q of 0 the input for something else, it will be the new value and not the value it had when we started the for loop. The non-blocking assignment using using this means use the values that everything had when you came into the always block. So for instance, if I had, before I start, I have a equals 1, b equals 2, c equals 3. And I have always at a, b, c. And I have b equals a, c equals b. After this always block, b will equal 1 and c will equal 1.
But if you did.
But if I do this, then b equals 1 and c equals 2.
2. Okay, I understand.
And especially when we're dealing with sequential circuits, we're often going to want that non-blocking because we don't want things to change right away. We want them to change on the edge of the clock. And that's the whole reason we use this. Okay. So now we're at the else. So the else means that y now equals 1. I mean 0. And on the else, I have, the else was q of 0 equals q of 1 or x. All right, so this is what q of 0 is going to equal. It'll equal q of 1, which is right here, ORed with some variable x. So I've just got x up here. But that's only when y equals 0, so it goes into the 0 of the multiplexer.
So at the beginning of the for loop, we have j can equal 0 or 1, right?
Well, j will first equal 0, and it'll run through, and then it'll run through, and j will equal 1. So I'm going to do that next.
Okay, sorry.
So it's sequential like that. So was that what your question?
Yeah, I was gonna.
Yeah. Okay. So now we get to, now that's the end of our for loop. So now we go back to the beginning of the for loop and we see, do we go again? And the answer is yes, we do, because now j will be equal to 1. 1 is still less than 2. So now we're going to do this for j equals 1. So I copied everything. Okay, so now j equals 1, and it says if y, I'll just go ahead and put in 1. Q of 1 becomes equal to the naught of q of 1 plus 1, else q of 1 becomes equal to q of 1 plus 1 or x. So if y, now I'm just going to write it in words. If y equals 1, q1 is going to equal q naught of q2. And if y equals, sorry, that's if y equals 1, because that was if y. If y equals 0, q of 1 becomes equal to q of 2 or x. So this if part is telling me to use the multiplexer. And the if y equals 1 means that I do what is equal to 1 into the 1 part of the multiplexer. So just like we did before, we said Q1 is supposed to equal the naught of Q2. So here's Q1. It's supposed to equal the naught of Q2. So it's going to equal the naught of Q2, but only if Y is 1. So it'll go into the 1 of the multiplexer. If Y is 0, then it'll equal Q of 2 or X. So I've got my variable X. I'll have an OR gate. And it goes into there. And I forgot to do the, I don't even have a correct QR code. Would someone, would y'all just pass this around and write your ID, which is just your email address. This is for 2742. Just write your email address and your name. There's no one in, there was someone in the Zoom, but they left, so there's no one there now. All right, so we got that. We're now done with the for loop.
So we erase the multiplexer.
Yes, so we can erase the multiplexer on the 2. Turns out we didn't need it. And now it says Q of n minus 1 becomes equal to A. Well, n is a parameter. N is 3. N is not changing. So this is just saying Q of 2 becomes equal to A. That just means there's some variable A, and Q of 2 is becoming equal to that. There's no if, so it's just going straight into it. Now we're outside the always block, and notice outside this always block, we're not using equals by itself or the non-blocking assignment, we're using the word assign. So outside the always block, we use assign and says assign B equal to Q of 0. So here's just a variable, B, and we just make Q of 0 equal to B. Okay, so I'm going to draw this neater now. Now that I know what it's supposed to look like.
I feel like they should give us more time if it.
They usually wouldn't be quite this long. This is actually an old homework question, but you could see something like this on a test. So
It's fair game.
yeah,
Are you going through all the problems today?
I'm planning on it. They won't all be this long.
Are you doing a video for each one?
What's that?
Are you making a video for each one?
Yes. Well, I'm actually probably just videoing the whole thing. Just having the whole thing.
Cool.
That doesn't mean, are you going to leave me?
Yeah, I have to go somewhere. I'm trying to finish this problem out.
Okay, so now let's answer the next part of the question, which said, and you're leaving me too?
Oh, I do have to go out.
Okay.
Gosh, the game just started.
Okay, so now it says beginning with Q equals 101. So Q is 101. So that means Q2 is 1, Q1 is 0, Q0 is 1. And A is 0, X is 1, and Y is 1. And it wants to know what are the next three states. Okay, so let's figure out, let's start with Q2. Q2 is going to be the easiest one because what is Q2 going to equal?
It'll equal to A.
Yeah, and what's A?
Oh, 0.
0. Okay, Q1. Okay, so Q1, well, it depends on what Y is. Y is 1. So that means it'll equal the not of Q2. But is it going to be the not of Q2 right now or the not of what Q2 was before? Before, because it was a non-blocking assignment. So it's not going to change. It'll be whatever Q2 was before we came in. So it'll be the not of Q2, which Q2 was 1. So the not of that is 0. And Q0 will be the not of Q1. Q1 was 0, and the not of that is 1. What's B going to be? B is going to be Q0, which is 1. Yeah, B is always going to be the same as Q0.
That's it?
That's it. Is A the next state or the next three states? Next three states. So, but now we know how to do it. It'll be easy. What's Q2 always going to be?
1.
Yeah. So Q2 is always going to be 1. And Q1 is, no, Q is 0. 0. It's A. Q2 is going to be 0. It's always going to be A. Q1 is going to be the not of Q2 before. And Q2 before was 0, so it'll be 1. It'll be 1. And Q0 will be the not of what Q1 was before. Before Q1 was 0, so the not of that is 1. And then that means this one, it will be 0. This is second and third.
Can you wait? Can you like re-explain how you got like Q1 in third state? Because like it says when y is 1, so because of
Keep
that, it
talking.
would just
No, you,
okay. So it would be whatever q naught is for the a2.
wait, for Q1? What is Q1?
Q1 is at y1. It would be the not q.
Not
For
Q,
q.
no. So what does the code say? What Q1 right here
Mhm.
would be the not of what?
Yeah. Then it would be in not q.
Not Q. No, there is no Q. The not of Q0, Q1, Q2.
Oh, 2.
Okay, so the not of Q2. Okay.
And that means the not of Q2. You check whatever it was Q2 before, and it was 0, so the not of that would be 1.
Mm-hmm.
Oh, okay. Then that's how you move second line. Second. Oh, same thing. Oh, well, because Q2 is always going to be 0, Q1 is going to always be 1. Okay, thank you. That I got the rest then.
Okay. Yep. That was it. Okay. All right. So now. Okay, I don't want to do this one right now because we just spent all this time with this, and that's gonna your brains will be a little bored with it. So I'm gonna skip 3 and 4. I will come back to them, and I'm gonna go to 5 just because that's gonna be a little bit different. Okay, so this one is talking about different kinds of counters and how they work. So starting with the starting with the 4-bit sequence 0101. What are the states of the following 4-bit counters after each clock cycle until the sequence repeats? Okay, so a ring counter is one where so like this, if this is Q0, this is Q1, this is Q2, this is Q3. The way a ring counter works is each bit gets shifted to the right. So it just moves to the right, and the one that's at the very end comes around and becomes the one at the front. So this would become, so the 0 moves here, the 1 moves here, and the 0 moves here, and the 1 at the end moves around to the front. And then for the next one, again, they each move 1 space to the right. And the 0 comes around to the front. And now you'll see we're back where we started. So for the ring counter, we had just the 2 states, and then it repeats. A Johnson counter is like a ring counter, except instead of this 1 moving around to the front, it complements when it comes around. It becomes the not of what it was. So these bits still move, but the bit at the end comes around to the front, but is complemented.
two states?
What's that?
It also,
No, because we have to get back to 0, 1, 0, 1. And I got to 1, 0, 1, 0, but I'm not back to the start yet. So the whole sequence all in all, so if I start with 0, 1, 0, 1, the next one would be, I'd have these three here, 0, 1, 0, and this 1 becomes a 0 in front. And then the next one would be 0, 0, 1, but that 0 would come in front as a 1. And then the next one would be 1, 0, 0 with a 0. And then the next one would be 1, 0, 1, 0. And then 1, 1, 0, 1. And then 0, 1, 1, 0. 1, 0, 1, 1. 0, 1, 0, 1. So that would be the whole sequence.
can you re-explain how you sequence from the start of 1, 0, from 0, 1?
From the very start?
So, just like say it once, like how does the sequence shapes? I didn't see it. From
It
0
shifts to the right, but the one at the end comes around to the front and
No,
complements
that's for
itself?
the ring counter.
No. A ring counter, it comes around to the front, but is not complemented. Johnson, it comes around to the front and is complemented.
Oh wait, so it does go to the front and then it just okay.
Okay, and then an up counter and a down counter. I just put these in there. I actually have never seen this on the test, but just so that you know how they work, they're just counters. They count up and they count down. So this is 4, this is 5, so the next one you'd get would be 6, and then 7, and then 8, and then 9, and then 10, and 11, and 12, and 13, and then 14, and then 15, and then back around to 0, 0, 0, and then 1, and 2, and 3, and 4, and 5, and then you're done. So it just counts up. A down counter, same thing, go in the opposite direction. Okay, I am going to stop this and start uploading this segment, and then so we're gonna take like a 3 or 4 minute break if y'all wanted to go get some water or something like that. And since no one seems to be on the Zoom, I will stop the Zoom, which means y'all need to be extra careful that I record because I won't have my backup recording.